So in this lecture, we are going to look at the carbonyl compounds. Now we are talking about the carbonyl compounds. We are basically looking at those functional group that have the carbonyl group. Is that okay? Any functional group that has this is known as a carbonyl compound, and there are about 4 to 5 of them. But most importantly, we have the aldehydes and the ketones. Right? Those are the two compounds that we are going to look at. Of course, the carboxylic acid and the derivative of the carboxylic acid also have a carbonyl group, maybe attached to any other functional group, depending on the derivative that we are looking at. Is that okay? Now, for the carbonyl group, you can see that here is called the carbonyl oxygen. This one here, oxygen here, is called the carbonyl oxygen. Alright, now this carbon here is called the carbonyl carbon. Is that okay? So we have the carbonyl oxygen and then we have the carbonyl carbon. Is that okay? Now, what is the discrepancy between aldehydes and ketone? Now, if you look at aldehyde, this is the functional group called aldehyde, while this is the functional group called the ketone. There's something peculiar to both functional group. What is that is peculiar to both functional group? You discover that both functional group have the aldehyde group. However, both of them also have an alkyl group. However, that of aldehyde has hydrogen attached to the carbonyl group at one end, while the ketone has another alkyl. I believe this is something that you should have learned in your secondary school and in your 100 level. So for ketones, they have two alkyl group, which is this alkyl group here and this alkyl group. While for aldehyde, they have an alkyl group, which is this, and a hydrogen atom attached to the carbonyl group. Is that okay? Example is something like this. If you have CH3, C double bond O H, this is an aldehyde. The aldehyde, they are also called alkanes. Why, if you have something like this, CH3, C double bond O, maybe CH2, CH3, this is a ketone. Why? Because this is one alkyl group and this is another alkyl group. When the two alkyl groups are not the same, you use arrow to represent one and then use arrow prime to represent the other. However, if the two alkyl groups are the same, you can either use arrow like this to tell you that the two alkyl group attached to this carbonyl group here are the same. However, if they are not the same, for instance, here is a methyl group, while here is an alkyl, this an ethyl group attached to this carbonyl. So that is the general idea of the carbonyl functional group. Now, we were also taught that if you have anything like this, let's say C double bond O, now here you have a pi bond and here you have a sigma bond. When you were taught that wherever you have a double bond, one of the bonds is a pi bond and the other bond is a sigma bond. And it is also worthy of note that this carbonyl group has a partial negative charge on the oxygen and a partial positive charge on the carbon. Why? Because the carbon or the oxygen tends to be more electronegative than the carbon, thereby withdrawing the electron cloud to the oxygen and then making the carbon to be positive charged. Note that whenever something gives out electron, it becomes positively charged, while that gains the electron becomes negatively charged. Now, in the context of what we have here, this oxygen is not completely withdrawing the electron, but to some extent it is dragging the electron cloud towards itself. When we say dragging the electron cloud, it means the electrons are more concentrated on the oxygen as compared to the carbon. So the oxygen will be partially negative. It is not full negative because the electrons are not completely transferred, while the carbon will be positively charged. Is that okay? So that is the discrepancy between the aldehyde and the ketone, and their peculiarity, their similarities are there. Is that okay? That is what we just looked at now. Now, what reactions do you think these carbonyl compounds will undergo? Of course, they have a double bond, which you can see here. Because they have a double bond, most double bonds, most compounds that have double bonds usually undergo addition reactions, like ketone, like alkanes and alkynes. Any compound most times that have a pi bond usually undergo addition reactions. So you should expect that this carbonyl compound will undergo addition reactions. All right. So that is that. Now, let's look at the nomenclature of aldehyde and ketone. Now, there are two systems of naming ketones. The two systems of naming ketone are, we have the common name, which you can see here, and then you have the IUPAC name, which you can see here. IUPAC means what? International Union of Pure and Applied Chemists. Are you getting it now? The common name is like the common name of calling this particular compound, and it usually goes like this. For instance, if you have CH3, C double bond O, CH3. For the common name, how do you call this compound? You call this compound by naming the two alkyl group attached to the carbonyl and then adding ketone at the end. You name the two alkyl group attached to this carbonyl and then adding ketone at the end. Now, here is methyl, here is methyl. So instead of you calling it methyl, because they are the same, you can say this is dimethyl. So this is dimethyl ketone. Is that understood? That is dimethyl ketone. Now, how about if these two groups are not the same? For instance, if you have something like the CH3, CO, CH2, CH3. Now, this is one group, while this is another group. Recall that we not bring in this carbonyl group in the middle. So what do you call this compound? This group here attached is a methyl group, while this here attached is an ethyl group. So what do you call this? Now, in alphabetical order, between E and M, which one comes first? You go alphabetically. So between E and M, which one goes first? Of course, E goes first. So you say this is ethyl, and here is methyl, and then you attach ketone to it. So this is ethyl, methyl, ketone. Is that okay? So that is that. So that is that for the common name. Now you can try this one as a practice question. So this is CH3, CH2, C double bond O, CH2, CH2, CH3. What do you think would be the IUPAC name for this compound? You can pause the video now and then try it out yourself. What do you think? I say IUPAC name, sorry, the common name for this compound. What do you think would be the common name for this compound? You can pause the video and then try. Now, by looking at it, you already know if you got this group here is an ethyl group, while this group here is propyl. So you say this is ethyl, E comes before P, ethyl propyl ketone. Alright, so that is that for the common name of the compound. Now, the next one is the IUPAC name. Now, for the IUPAC name, what you normally do is to number in such a way that the carbonyl group have the lowest numbering. Is that okay? So we are also going to name all these using the IUPAC nomenclature. How do we do that? You say CH3, COCH3. Our numbering, of course, will be here will be 1, here will be 2, here will be 3. So what do you think is the name of this compound? You say, at what position do you have this ketone group here? Position number 2. So you say this is 2. How many carbons altogether here? 1, 2, 3. Normally 3 carbons in alkane is propane, but because you are talking about the ketones, which IUPAC they are referred to as alkanones. Alright, so you just change the alkane name and then put the none to it. So because you have propane, you change the E and then put it as a propanone. So this becomes 2-propanone. Now sometimes some persons may still say this is, without writing the 2 first, propane or propan 2-one, to show to you the position of the ketone group. Alright, so let's see another one quickly. How about this one we have here? This CH3, C double bond O, CH2, CH3. How do you name this compound using the IUPAC nomenclature? Now this one would be the numbering. If you number from this side, you have 1, 2, 3, 4. That will not work now, because you can number from here 1, 2 in such a way that this carbonyl group will be at position number 2. So this is also 2. Number of carbon 1, 2, 3, 4. So you say this is 2-butanone. Alright, 2-butanone. Is that okay? So that is that for, and then this one you can say 1, 2, 3, 3, 4, 5, 6 hexanone. So you say this one is 3 hexanone or hexan 3-one. Alright, so that's that. Now for the aldehyde, the nomenclature of the aldehyde, you also use the common nomenclature and then you also use the systematic nomenclature. Now for instance, if you have something like this, CH3, C double bond O, and then H. Now this one, the common nomenclature will be ethane. Normal, it's supposed to be ethane because it starts with carbon, but because it's an aldehyde, you call it ethanaldehyde. Ethanaldehyde. Aldehyde. Now all you needed to do was to remove the E. You know, ethane is something like this. So all you needed to do was remove this E of ethane and add aldehyde to it. So this all gives us ethanaldehyde. Now the next one we are going to look at is something like this: CH3, CH2, C double bond O, H. Now this one is called propione. Now you call it normally propane, you don't call it propanaldehyde, but this one you call it propione aldehyde. And then that of butane, there's a name, there's a way we can call that of butane. Alright, you call it what? Butyraldehyde. It's quite different from the other ones. Butyraldehyde, they use their common nomenclature. Then for that of 5, valeraldehyde, and so on and so forth. Then if you now come to the IUPAC nomenclature, that is when you have it called the alkana. From the IUPAC nomenclature. So this compound you see here, if you come to the IUPAC nomenclature, this compound, you call it ethana. Alright, this compound, you call it as propana. Then that of butane, you call it as butana for the IUPAC nomenclature. It's not something that is very, very hard for any one of us to do. The next thing is this preparation. Now, the first means of preparing aldehydes and ketone is by oxidation of alcohol. Now, One thing that you should know is that primary alcohol, they also call 1 degree alcohol, they are usually oxidized to aldehyde. Now this oxidation may also proceed to give us carboxylic acid.